World's oldest poisoned arrow discovered. 60,000-year-old Stone Age weapon still contains active toxins. Archaeologists have identified the oldest known evidence of poisoned arrows in the world after detecting toxic plant compounds on 60,000-year-old Stone Age arrowheads from South Africa. Remarkably, some of these chemical substances remain biologically active even today, offering rare insight into the advanced hunting strategies and cognitive abilities of early humans. Now, let's get into this story in detail on the AI podcast.
Imagine holding a weapon, an arrowhead, that was made 60,000 years ago.
It's hard to even conceive of that time scale.
Right. Now imagine that same weapon. It still has active, traceable, poisonous chemical compounds on it.
And that's the key. It's not a movie plot. This is real archaeology.
It's the ultimate example of truly ancient knowledge. A chemical formula for hunting, perfected when, much of the world was still deep in the Ice Age. Today, we are doing a deep dive into findings that have just completely changed how we see the intelligence of early Homo sapiens. Our mission is to unpack what this stunning breakthrough tells us about ancient chemistry, planning, and, the true history of human innovation.
And we can really dig into this with confidence because we are not just talking about, inferences or educated guesses here.
No circumstantial evidence?
Exactly. The core of this comes from a major study in the journal Science Advances. And they didn't just guess based on the shape of a tool. They used incredibly sophisticated analysis to directly detect the toxic compounds on the Stone Age artifacts themselves. That direct chemical proof, that is what makes this so revolutionary.
Okay, let's unpack this. Let's start with just the timeline, because the shift we're talking about is enormous. So to set the scene for you, we're going back in time to the Umhlatuzana Rock Shelter. It's in KwaZulu-Natal in South Africa.
A real treasure trove for early human history.
It really is. And it's here that archaeologists found these seemingly unremarkable little quartz arrowheads.
Unremarkable maybe until you get the dating back. These artifacts are confirmed to be about 60,000 years old.
And that number is it's almost impossible to really grasp.
Well, let's try to put it in context. Think about all of written history, from the very first cuneiform tablets in Mesopotamia right up to today. That's only about 5,000 years.
Okay, so 5,000.
This discovery predates that entire period by more than 11 times.
Wow. It's just a phenomenal time jump. So why is 60,000 years such a game changer for this specific kind of technology?
Because it just completely shatters the existing timeline. Completely. Before this find, the earliest confirmed use of poisoned arrows anywhere in Africa was dated to about 7,000 years ago.
7,000. And we're jumping to 60.
We are pushing confirmed technological sophistication back by 53,000 years. It's a massive, massive leap.
So we're not just talking about the invention of the bow and arrow itself, which is already a huge cognitive step.
Right.
We're talking about the simultaneous invention of, a kind of chemical warfare technology to make that tool even deadlier.
Exactly. That's the thing. It implies these early people didn't invent the bow and then thousands of years later figure out how to improve it. They seem to have figured out the physics of a projectile and the complexity of organic chemistry almost at the same time.
It's a dual innovation.
It is, and that's what makes Professor Marlies Lombard's work so profound. She points out that our ancestors didn't just invent the bow earlier than we thought. They also had this fundamental grasp of nature's chemistry to, make their hunting way more efficient. It's advanced mechanics and advanced toxicology hand in hand.
Which brings us to the technical challenge.
Yeah.
How on earth do you confirm a toxin after 60,000 years? If I leave some food outside, it's gone in days. We're talking about trace organic material.
This is where the modern science is just incredible. A technological feat in its own right. They were dealing with microscopic residues, not some thick layer of goo.
Right.
So to get around that, they use the most sensitive instruments we have. Things like Fourier transform, infrared spectroscopy, FTIR, and gas chromatography mass spectrometry, GCMS.
Okay, so in plain English, what does that actually mean they did?
It means they could gently scrape the surface of these quartz arrowheads and isolate just tiny, tiny molecules. The instruments then analyze those molecules by looking at their unique energy patterns. Every organic compound, like a specific plant toxin, has a unique chemical signature.
Like a molecular barcode.
That's a perfect way to put it. Even in tiny amounts, these methods can find and confirm the presence of very specific, complex, organic stuff.
And I guess the quartz itself must have helped preserve that signature.
It did, yeah. Quartz is very non-porous and durable. So when the poison was applied all that time ago, the organic compounds would have seeped into these microscopic cracks on the stone's surface. The stone became a kind of chemical time capsule.
So the chemical signature they found, it pointed to a specific plant. What was this 60,000-year-old weapon made of?
The fingerprint led them straight to a plant called Buffon disticha.
Okay.
It's a type of bulbous plant, and its local name in southern Africa is gifbol, which literally translates to poison bulb.
So no ambiguity there.
None at all. It's incredibly potent. It's still used very cautiously in some traditional medicine today, but it is primarily known for being lethal.
And how lethal are we talking? What do the gift bowl toxins actually do?
The plant is full of powerful cardiotoxic and neurotoxic alkaloids. For a person, if you ingest it or get it in a wound, the symptoms are terrifying. We're talking severe nausea, visual problems, respiratory paralysis, and then coma and death.
Wow.
The paper even noted that lab studies on rodents show that extremely small doses were fatal in about 20 minutes. This is serious, fast-acting stuff.
So is the point to kill the prey instantly?
Well, not necessarily, and this is where the context is so important. When you're hunting large animals, antelopes, buffalo, it's not just about a quick kill, it's about control.
Right. If you hit it and it runs for 5 miles, that doesn't really help you.
It doesn't help at all. You might lose it completely. So the experts argue that the main function of the poison was probably to weaken or slow the animal down dramatically. The goal wasn't instant death.
It was about making it trackable.
Exactly. The toxicity meant the animal couldn't run far. It might collapse within a much smaller radius. And that requires patience, a deep trust in your chemistry. You hit it, and then you wait, knowing the poison will do its work.
Here's where it gets really interesting, because the ultimate proof here is the stability of the compound. The fact that they could identify the poison is amazing, but the truly mind-boggling part is that it's still chemically active after 60,000 years.
That chemical stability is the whole story. I mean, most organic compounds just break down, but the specific alkaloids in gifbol are incredibly stable, even over that kind of deep time. Professor Sven Isaacson, one of the chemists on the project, confirmed it. He said the compounds they detected are still active components. They are still technically poisonous.
But not enough to be dangerous to the researchers handling them out, right?
Yeah.
Oh, correct. As he explained, the concentrations they found are way too low to be deadly today. They're just trace elements. But the molecules themselves, their actual structure, have remained chemically functional. That incredible persistence is probably why this specific knowledge could be passed down for so long. The stability of the substance reflects the stability of the tradition. If we connect this to the bigger picture, that continuity of knowledge is maybe the most profound piece of this entire discovery. The researchers didn't just stop with the 60,000-year-old arrowheads.
They wanted to see if it was a one-off.
Exactly. Was this a fluke, or was it part of an unbroken technological tradition?
So they looked for that continuity by comparing these ancient artifacts to much more recent ones.
Precisely. They got their hands on poisoned arrows that were only 250 years old. They'd been collected by European travelers back in the 18th century and were sitting in Swedish museum collections.
And these were made by the descendants of the same people.
The direct descendants, yes. And what they found was genuinely shocking.
What was it?
These much later arrows showed evidence of the exact same plant-based poison.
You're kidding. The same chemical formula.
The same chemical formula from the same plant, used for the same purpose, spanning a period of time longer than modern humans have even existed in Europe.
That is absolutely mind-blowing. It suggests this continuous, effective chemical tradition that lasted for tens of thousands of years. It's not just an artifact. It's like a living textbook passed down generation to generation.
It really is.
But okay, let me play devil's advocate for a second. Couldn't that just be because that specific plant was the most toxic one around? Maybe it was just rediscovered over and over again rather than the knowledge being passed down directly.
That's a totally valid point. And if the artifacts were from all over the place, or if they showed a mix of different poisons, that hypothesis would be pretty strong.
But that's not what we see here.
No. We see geographical continuity and, more importantly, this highly specific chemical consistency. Making an effective poison from gifbol isn't as simple as just rubbing the bulb on an arrow. You have to know how to process it, how to extract the alkaloids, how to prepare the adhesive to make it stick.
As a whole procedure.
The very specific procedure. And to get the exact same chemical result in the 18th century as they did 60,000 years ago, I mean, that is the very definition of an enduring technological culture. This was standardized knowledge transfer. It shows this formula was so successful that it was maintained, not constantly reinvented.
Which brings us back to the cognitive leap this represents. Using a weapon that takes time to work requires a totally different mindset than, say, throwing a spear for immediate impact. It demands planning, patience, a clear grasp of delayed cause and effect.
Absolutely. The use of arrow poison is fundamental proof of advanced cognition. It's a multi-step process. You need the foresight to find the plant, the knowledge to process it, the skill to make the bow and arrow, and then the patience to track the animal while the toxin works.
It's sophisticated risk management.
It is. You're investing all this time and energy knowing the payoff might be hours away. Professor Anders Hugberg summed it up perfectly. He said, "Using arrow poison requires planning and foresight. It is a clear sign of advanced thinking and reflects cognitive abilities similar to those of modern people." This wasn't primitive. This was high-tech, chemically assisted hunting.
So this discovery is really redefining what we thought early Homo sapiens in southern Africa were capable of. They weren't just surviving, they were intelligent innovators using complex chemistry, and they were just profoundly connected to their environment in a way that gave them this incredible technological edge. So to synthesize what we've unpacked for you today, the earliest direct evidence of poisoned arrows is now 60,000 years old from South Africa. The poison was the highly potent gift bulb plant found using cutting-edge science. And maybe most importantly, the fact that this specific chemical knowledge was maintained for over 50 millennia is profound evidence that our ancestors had planning, foresight, and a tradition of scientific knowledge that was, equal to our own.
What's fascinating here is that the physical stability of that one chemical compound, that tiny molecule, is literally what allowed for the historical stability of an entire technological tradition. The chemistry made the history possible. And if you think about it, if a deep, effective understanding of plant chemistry enough to create targeted chemical weapons existed 60,000 years ago and was maintained so perfectly, it really makes you ask a bigger question, doesn't it?
Which is,
How many other foundational scientific concepts that we think of as modern were actually mastered and maybe lost by our most ancient ancestors? Perhaps the full scope of human technological history is far, far longer than we've ever imagined.
Okay, one question for you. How does the discovery change our understanding of early human hunting techniques? Don't forget to comment it. Thanks.